Welcome viewers, in this video we'll see the design of 1:8 demultiplexer using two 1:4 demultiplexer. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. We need to design the 1:8 demultiplexer using two 1:4 demultiplexer. We know that multiplexer is a device that having only one input, 2 to the power n output and n number of selection lines. So this is the basic structure of the demultiplexer. One input, 2 to the power n output and n selection lines. So here one input, the n is 3, 2 to the power 3, 8 outputs, and 3, n is 3 means 3 selection lines. Similarly here one input, 2 to the power 2, 4 outputs and 2 selection lines, right? So we have here 3 selection line, here 2 selection lines. This selection line will decide the output. Having one input with n number of output is decided by the selection line, right? Now we'll see this design step by step. Step 1, connect the D in. This is the input, only one input. Signal to D in input of both the multiplexer. So the input signal is given to both the multiplexers. So we are using two 1:4 demultiplexer to design 1:8 multiplexer. So both the multiplexer we connected the D in signal. Input signal is connected to both the demultiplexer. Now we'll see the selection lines. So there are 3 selection lines for 1:8 multiplexer. 3 selection lines. Let us consider the 3 signals A, B, C. So this is the most significant bit. This is least significant bit. This most significant bit is used for enabling the demultiplexer. Because we have two 1:4 demultiplexer available, we need to enable one demultiplexer at a time. Another multiplexer is disabled. So the signal A is used for enabling the multiplexer. Then B and C used for selection line. For 1:4 multiplexer, we need only 2 selection lines. So B and C used for the selection line of the demultiplexer, both the demultiplexer, B and C. For example, B used as S1 and C used as S0, right? So the input D in is given to both the multiplexer. In this among A, B, C, three signals, in 1:8 we have 3 selection lines are there. In that, the most significant bit is used for enabling the demultiplexer. Then least significant bit C and B used for selection line of the 1:4 demultiplexer, right? So it is given here. Connect the selection lines B and C to select the line of S1 and S0 of the both the demultiplexer respectively, right? Now we'll go to the step 3. The connect most significant bit, that is A, such that when A equal to 0, dmux1 is enabled. Because A is equal to 0 means it is given in inverted by using the NOT gate. So A equal to 0 means dmux1 is enabled. When A equal to 1, dmux2 is enabled, right? So now we decided the input D in given to both the multiplexer. Selection line B and C. Enabling the dmux is A, right? So based on that, now we'll go to the diagram. So this is the logic diagram. So this is first demux 1:4 demux1. This is next demux 1:4 demux2. We are using two 1:4 demux, right? So this is the corresponding output y0, y1, y2, y3. Similarly y4, y5, y6 and y7. There are 8 outputs. So that we'll get 1:8 output. So the D in is the signal, input signal that is given to the dmux1 as well as dmux2. The input D in is given to both the dmux, right? And the selection line, this is 3 selection line for 1:8 multiplexer. In that, but for 1:4 demultiplexer we need only 2 selection lines. So that the first one, most significant bit, is used for enabling the demux, right? If A is given through the NOT gate, let's say, so if A equal to 0, here it become 1, so dmux1 will be enabled. A equal to 1 means here 0, dmux1 will be disabled. this one is applied to the second demux. So if A equal to 1 means demux 2 will be enabled, right? So the signal A used for enabling the demux, either 1 or 2. This B and C is connected as a selection line for 1:4 demux. B is connected as S1, C is connected as S0, right? So input is given to both the demux. The most significant line signal A used for enabling the demux. B and C used for selection line of demux 1 and 2. Both demux 1 and 2, it is a selection line, right? So what will happen if it is demux 1 is enabled? It is 0 0 means we will get y0 as the output. 0 1 means y1 as the output. 1 0 means y2 as the output. 1 1 means y3 as the output. Similarly here, at a time only one demux will be enabled, another demux will be disabled, right? So based on that, we'll go to the truth table. Now we'll see the truth table. So this is the truth table of the 1:8 multiplexer using 1:4 demultiplexer. Let's see the three selection lines A, B, C. Three inputs of three selection line of the 1:8 demultiplexer. In that A used for enable. S1 and S2 used as B and C. B and C used as S1 and S0 as a selection lines, right? So this is the 8 outputs: Y0, Y1, Y2, Y3, Y5, Y4, Y5, Y6 and Y7, right? 1:8 outputs are available, right? If the enable, the signal A, enable is 0. 0 means the demux 1 will be enabled because it is given through the NOT gate. So demux 1 is enabled, that is we will get the output from Y0 to Y3, that is A equal to 0. At the time demux 2 will be disabled. Demux 2 is disabled, we will not get any output. See this, when A is 0, this Y0 to Y3 will get the output. This Y4 to Y5 all are zeros. This is demux 2 is disabled. Only demux 1 is enabled. In that, if it is B and C is 0 0 mean the out data available in Y0. 0 1 means data available in Y1. 1 0 means data available in Y2. 1 1 means data available in Y3, right? So we'll get the data Y0, Y1, Y2, Y3. These are all zeros. All outputs are zeros, right? Then if it is enable is 1, what will happen? demux 2 will be enabled. Demux 1 will be disabled. So that will get the output from Y4 to Y7 when A equal to 1. See this demux 1 is totally disabled. All are zeros. Demux 2 is enabled. In that, again it is 0 0. The selection line 0 0 mean we will get the output in Y4. If it is 0 1, we will get the output in Y5. 1 0 will get the output in Y6. 1 1 means we will get the output in Y7. So we are getting the output from Y4, Y5, Y6 and Y7. These are all zeros, right? So by seeing the complete truth table, see that we got the output from Y0, Y1, Y2, Y3, Y4, Y5, Y6 and Y7. So this is the 8 different outputs, right? So we are getting the output of 1:8 demultiplexer by using the 1:4 2 demultiplexer. This is the total output of the 1:8 demultiplexer, having only one input with two selection lines. One is used for enable, another two used for the selection line, right? So first to 4 output, demux 1 is enabled, 2 is disabled. Remaining 4 outputs, demux 1 is disabled, demux 2 is enabled. So that we are getting the corresponding inputs from Y0 to Y7. So in this video, we discuss how to design the 1:8 demultiplexer using two 1:4 demultiplexer. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers. In this video, we'll see the implementation of 1:16 demultiplexer using 1:4 demultiplexer. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. We need to implement 1:16 demultiplexer using 1:4 demultiplexer. We know that the multiplexer is nothing but 1:2 to the power n with n selection lines, right? Only one input, 2 to the power n outputs with n selection line. This is the basic structure of the demultiplexer. This n selection line will decide the 2 to the power n number of outputs. From the one output we are getting 2 to the power n output, that is decided by n selection lines. So this 1:16 demultiplexer means it is nothing but 1:2 to the power 4 and 4 selection lines, right? One input, 16 outputs are available, that is controlled by 4 selection lines. 1:4 mean 1:2 to the power 2 with 2 selection lines, right? So this is having one input with 4 outputs and controlled by the 2 selection lines, right? Suppose we want to implement 1:16 multiplexer, that is 16 outputs we need, means here we are using 1:4 demultiplexer. So 4 outputs are available, but here we need 16 outputs. So we need to use 4 numbers of 1:4 demultiplexer. We need to use 4 number of 1:4 demultiplexer, so that 4 into 4 will get 16 outputs, right? So for both the case only one input, right? Here 4 selection lines are available, but here we need only 2 selection lines, right? So in this let us consider S3, S2, S1, S0. These are all the 4 selection line in the 1:6 multiplexer. In that the least significant bit S1 and S2 is used for the selection line of 1:4 demultiplexer. For all 4 demultiplexer we can use S1 and S0 as a selection lines, right? Suppose 0 0 mean it will select the dmax 1, 0 1 mean it will select the dmax 2, 1 0 means dmax 3, 1 1 means dmax 4. So the selection line will select out of 4, it will select any one dmax, right? What about this another 2 selection lines, right? Here we are having 4 dmax. In order to select these 4 dmax, we need one more dmax. One more dmax is needed. So that dmax will select out of 4 dmax, it will select any one, right? So here we have 4 dmax, that is controlled by least significant bit of the selection line S1 and S0. That 4 demultiplexers are controlled by one more dmax is needed. For that one more dmax we are using this S3 and S2. That is the most significant bit, right? So we'll see the block diagram, you are able to understand clearly. So that is our basic concept. We'll see the description. The 1:6 demultiplexer have 16 outputs. To select one of the 16 output, the circuit need 4 selection lines. Each 1:4 demultiplexer require 2 selection lines, right? So connect 2 least significant bit S1 and S0 to select the 4:1 multiplexer, right? That what we discuss, S1 and S0, right? The step 2, second step is connect one more 4:1 demultiplexer such that 4 outputs are routed to the data input of 4 demultiplexer. Here we are using 4 demultiplexer, that is controlled by one more 4:1, 1:4. It is a 1:4 demultiplexer, right? 1:4 demultiplexer. For that we need to connect the MSB S3 and S2, right? Now we'll go to the block diagram how we are connecting. So totally we are having 5 dmax, 4 dmax, that is controlled by one more dmax. Now we'll see the block diagram. See this is the dmax, second dmax, then third one, fourth one and fifth one, right? So that these 4 dmax are selected by one more dmax, is this one. So that is named as dmax 1. This is the 5th dmax. This dmax will select the remaining 4 dmax, so that it is named as dmax 1, right? The data input is given, only one input. It is controlled by the selection line S3 and S2, MSB, right? Suppose it is 0 0 means the y0 output will be available in y0. 0 1 means output available in y1. 1 0 means y2. 1 1 means y3. Right. So this y0 is connected to the dmux2. Right. This y0 is connected to dmux2. y1 is connected to dmux3. Then y2 is connected to dmux4. Then y4 is connected to dmux5. Right. So this dmux will route the inputs, route the available inputs by to this 4 dmux. Right. 0 0 means first one, 1 0 0 1 second, 1 0 third, 0 1 1 means 4. Right. So these 4 dmux are controlled by this one more dmux with one data input. This data will be given to any one of this dmux based on the selection line. Right. Now these 4 are controlled by this dmux. Now we'll see this control of this dmux one by one. Right. So this is dmux2. It is named as dmux2. So when the selection line MSB S3 and S2 is 0 0 mean this dmux will be enabled. Right. This dmux will be enabled. Remainings are disabled. So it got the input. Remaining inputs are 0. Right. In this again here we have two selection lines are available. These two are nothing but this is S0 and S1. It is connected to all the dmux. The selection line is connected to all. Here 0 0 mean this. First data D0 will be enabled. 0 1 means D1 will be enabled. 1 0 means D2 will be enabled. 1 1 means D4 D3 will be enabled. Or remaining all remainings are zeros. Right. So the selection line 0 0 means the dmux2 will be enabled. In that again two selection lines are available, 4 combination based on that this any one of the data will be enabled. Remainings are 0. Suppose the data line, the selection line 0 1 means dmux3 will be enabled. Right. In that again is connected with S0 and S1. 0 0 means D4. 1 0 means D5. 1 0 1 0 means D6. 1 1 means D7. Again based on the selection line. Then the selection line S3 and S0. 1 0 means dmux4 will be enabled. Again here it is connected with the MSB selection line S0 and S1. It is 0 0 means D8. 0 1 means D9. 1 0 means D10. 1 1 means D11. Right. So then the selection line this 1 1 means this fifth dmux will be enabled. Again here see this S0 and S1 is connected. 0 0 means D12. 0 1 means D13. 1 0 means D14. 1 1 means D15 will be enabled. In that case remainings are 0. Right. So we are having 4 dmux, so that we are getting 4 into 4 16 output. That is controlled by one more dmux. 1:4 dmux. That dmux is controlled by selection line S3 and S2. These 4 dmux are controlled by the selection line S0 and S1. Right. So that we are getting 16 different output. Now we'll refer the truth table so that we are able to understand clearly. Now we'll see the truth table. Now refer this truth table. This is selection lines S0, S1, S2, S3. These are all the 16 different outputs starting from 0 to 15. 16 different outputs are available. We already know that S1 and S0 is connected to all 4 dmux. S3 and S2 is connected to the one more dmux. In order to control the other 4 dmux, this S3 is S2 is connected to the one more dmux. Right. So in this S3 S2 is 0. If it is 0 means what happened? This dmux2 will be enabled. Dmux2 will be enabled. That is we got the data from D0 to D3. Right. So S3 S2 connected to the main dmux. If it is 0, the first dmux, that is second dmux, dmux2 will be enabled, the data from D0 to D3. Right. In this again there are 4 combinations. If it is 0 0, the data, first data will be available. D in available in the first position. 0 1 means second position. 1 0 means third position. 1 1 means fourth position. All remaining data are zeros. These demux are not enabled. Only this demux2 is enabled. We are getting the data from D0 to D3 based on this selection line S1 and S0. Right. Suppose if it is 0, 1, next combination 0, 1 means demux3 will be enabled. So that we are get the data from D4 to D7. Right. So this D4 to D7. This D0 to D3 is the first demux is disabled. Third and fourth demux also disabled. Right. Only the second demux is enabled. In that 0, 0 means data available in fourth position. 0, 1 means fifth position. 1, 0 means sixth position. 1, 1 means seventh position. Right. These remainings are zeros or not enabled. This demux2 is disabled. Only 3 is enabled. 4 and 5 also disabled. Right. In this we will discuss 0, 0, 4 combination. 0, 1 also 4 combination. Then we will go for 1, 0. Another 2 combinations available. 1, 0. If it is 1, 0, what happened? If 1, 0 means demux4 will be enabled. That is, we got the data from D8 to D11. Right. 1, 0. And again it is based on these 4 selection lines. 0, 0 means 9th position. 0, 1 means 10th position. 1, 0 means 11th position. Sorry, 8th, this is 8th position, 9th position, 10th and 11th position. This demux2 is disabled. Demux3 also disabled. Only demux4 is enabled. Demux5 also disabled. Right. So it will enable only demux4, that is got the data from D8 to D11. So one more combination available, 1, 1. If it is 1, 1, demux5 is enabled. We got the data from D12 to D15. Again in the selection line S0 and S1. 0, 0 means data available in 12th position. 1, 0, 1 means 13th position. 1, 0 means 14th position. 1, 1 means 15th position. This demux2, demux3, demux4 is disabled. Only demux5 is enabled. We got the 4 different output based on this selection line. Right. So this is the implementation of 1:6 multiplexer. We have got the 16 different output by using 4 demux. 1:4 demux. There are 4 demux. Right. So in this video we discuss implementation of 1:16 demultiplexer using 1:4 demultiplexer. We discuss the design procedure, logic diagram and truth table. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.